Hello and welcome. In this video we're going to look at 8.1 example 2, which asks find the length of the curve f of x equals x to the third over 12 plus 1 over x. And by the way, that's a comma right above the x. It's not a prime or a power of 1, it's just a comma. And we're doing this from x equals 1 to x equals 4. Figure 6 shows a picture, just some curve. You don't have to have the picture for these problems. It just helps to, kind of know that there's a picture behind the scenes. So we're going to find how far it is to walk from this point on the curve at x equals 1 to that point on the curve at x equals 0. Well, the first thing we're going to have to find is the derivative of our function. So here we're going to multiply the 3 in front, subtract 1 from the exponent. You'll get x squared over 4, and then minus 1 over x squared when you take that derivative. Remember, you can take the 1 over x, write it as x to the negative 1, and then the negative 1 multiplies in front, subtract 1 from the exponent to get a negative 2 exponent, so you have minus 1 over x squared. Now to find the arc length, we're going to integrate from 1 to 4, the square root of 1 plus the derivative of our function squared dx. So we can put in the derivative of our function, 1 plus x squared minus 4 over 1 over x squared, quantity squared dx. And now, there's not really a way that we can see at this point to find an antiderivative, so let's just do some algebra, try to clean things up a little bit. We have integral from 1 to 4 of 1 plus, if we expand that out, that square the x squared minus x squared over 4 minus 1 over x squared, we'll get x to the fourth over 16. Now the middle term, remember when you expand a plus b squared, remember it's a squared plus 2ab plus b squared, right? When you expand a binomial like that, a binomial squared. So the middle term is 2ab. Well, let's think about what the middle term would be in this case. It's going to be 2 times x squared over 4 times 1 over x squared. Notice that, so 2 times x squared over 4 times 1 over x squared. So notice that the x squareds are going to cancel. And you'll just get 2/4, which is 1/2. So we have minus 1/2, because it's actually a minus 2ab, there's a negative in the middle, and then plus 1 over x to the fourth dx. Now the next step is going to be something key is going to happen in the next step. It's going to be an important step to take. So in the next step, we're going to combine like terms. We're going to do 1 minus 1/2. Feels like not a very key step, but something's going to happen. Notice that when we do 1 minus 1/2, we get plus 1/2. So by taking this negative 1/2 and adding the 1 to it, it effectively flips the sign of the negative half to a positive half. This may seem a little weird to spend time on that, but it's going to really help us evaluate this integral. So what we have is the square root of x to the fourth over 16 plus 1/2 plus 1 over x to the fourth dx. Now at this point it feels like we're stuck. It feels like, how are we going to go on? I mean, maybe we could get a common denominator here, and that's one way of thinking about it. But there's a trick that if we notice it, then we can make our lives a lot easier. And the trick is this. This x to the fourth over 16 minus 1/2 plus 1 over x to the fourth came from squaring x squared over 4 minus 1 over x squared squared. It came from squaring that expression. Now, if all that happens from between this last step that we just took and the step right before that, if all that happens is the negative in front of the 1/2 changes to a positive 1/2, then we know exactly how the stuff under the radical here factors. We can factor it out as the integral from 1 to 4, here we go, square root of x squared over 4 plus 1 over x squared. Now, I'm not sitting here thinking about how to factor this trinomial. I'm just looking at the fact that it used to be x squared over 4 minus 1 over x squared squared. And now, instead of in the middle we have a minus 1/2, we have a plus 1/2. That's just going to make the middle sign of that factored version positive, right? If all you do is just flip it from positive to negative, like over here, if we have a minus b squared, that's a squared minus 2ab plus b squared. These things will factor the same way. These trinomials will factor the same way. It's just that instead of having a minus in the middle, you'd have a plus in the middle. Or instead of having a plus in the middle, you'd have a minus in the middle, depending on what the situation is. So if you notice that, then it makes things a lot easier, because now the square root will be gone. When you take the square root of this expression squared, they disappear. So you just get the integral from 1 to 4 of x squared over 4 plus 1 over x squared dx. And now we can integrate term by term. Find the antiderivative term by term. Add 1 to the exponent to get x to the third. Divide by 3, which gives you 12 when you multiply it to the 4. Then you have the integral of 1 over x squared, which is minus 1 over x, from 1 to 4. So then we get 4 to the third over 12 minus 1/4 minus, and then 1 to the third over 12 minus 1 over 1. Here, it's a lot of fraction work. I'm going to put a little ... and you should get 6. So that's just a little trick that sometimes comes up in the homework problems. You'll get some negative half turning into positive half, and then everything will factor exactly how it did a moment ago. It's just that you'll have a positive in the middle instead of a negative in the middle. Now, one last note before we leave is that if you have x as a function of y, as opposed to y as a function of x, which is what we saw in example 1 and 2. So if you have x as a function of y instead, then we can write the arc length integral as the integral from a to b of the square root of 1 plus dx dy squared, and then dy. So there, if you have x as a function of y, as long as it's a function of y, you can still use this arc length formula. You'll just have a dx dy inside, and then everything will be integrated in terms of y. It'll be a dy outside here. So thanks for watching, and see you next time.